Welcome, ladies and gentlemen, to your section 7.4 note guide. This will be a part A video about logarithms and logarithmic functions. Down here are our objectives. We're going to first learn how to graph a logarithm, then we'll evaluate logarithms, and then we'll rewrite them from logarithmic form to exponential form, and back and forth, actually. Notice that they are bringing exponents into here, and really that's the gist of what a logarithm, or there's a relationship, I should say, to exponentials, and it says it right here. Logarithmic functions are inverses of exponential functions. Now, what does that mean to be an inverse function? Well, that is where last semester, inverses, you would have talked about how an inverse is where you switch x and y values. So all it means is that every x value for the one function is now the y for the other, and vice versa. And you know what's really, really interesting is then when you graph an inverse against the original, the graphs will reflect across the y equals x axis, or line, I should say. So let me just write that here because that's really important. So the graphs reflect across y equals x. And that's, I'm going to demonstrate that down here, where we have an exponential function, y equals 3 to the x power. And then over here, notice I'm calling it a logarithmic function, and instead of it being y equals 3 to the x, it's x equals 3 to the y. So we literally just changed the y to x and the x to y. And we're going to get into this, but really this function right here can be rewritten as y equals log base 3x. And we're going to talk a lot about that here in just a bit. But let me first just kind of get this idea of what an inverse is so that you can kind of at least see visually what they are, what a logarithm is, and a function anyway, and kind of connect it from there. So an exponential, you know, we've done these. So obviously, you know, we're putting the negative 2 in for x. So if we have y equals 3 to the negative 2, leaving it as a fraction, that would give us 1/9, because of course that negative exponent means it goes down into the downstairs, or the denominator. So it would be, this is the same thing as 1 over 3 squared, which is then 1/9. If I put negative 1 in for x, you end up with 1/3. If we put 0 in, and we love 0 as an exponent because 3 to the 0 power would give us 1. Anything to the 0 power, of course, gives us 1. And I'm going to get this out of here just so that I have more room. So this is 1. And then if I put 1 in, I get 3. And if I put 2 in for x, I get 9. And if I graph those, and I'm going to graph them as well as I can here. So negative 2 1/9 is, ooh, it's like really close to the x-axis. Negative 1 1/3 is about right there. 0 1 is right here. 1 3, and we've graphed exponentials, so this should not be too difficult for you. And of course we have the asymptote of the x-axis, and I'm going to try very hard to get a good graph in here, and here we go. Oof. Okay, so there is the graph of y equals 3 to the x. Now the domain, as we've talked about before, it's all real numbers. The range is y is greater than 0. The asymptote, of course, is y equals 0, which is the x-axis. The x-intercept, there isn't one. And the y-intercept is, in this case, the magic 0.01. Or I always think of it as a magic point, which is, of course, that right there. Okay, so let's talk now about a logarithmic function. So nothing we've done so far is new, but now what we're going to do is switch the x's and y's. Now, I am going to say this. If you notice that all the x's here, right here, all the x's right here, I'm going to now erase that because I don't want to actually cross it off, are now the y's here. So I'm going to just make sure, again, you realize that all we're doing is switching the x's and y's. So really, if that's the case, then we know that the table, if we do it long-handed, you'll get these same values, but all I'm doing is flipping the table around. And then if we graph it, this is where you have to be a little bit careful. And yeah, I was just gonna say, let me switch colors just because I can, right? So this is the green table, and I'm going to actually, oh, look at me. If I had thought about this, I'm gonna color coordinate here just to make it a little bit easier for us all to kind of follow everything. I'm gonna do 1/3, and you could be graphing these, of course, on your graph. So we have 1/9 -2. What does that look like? That's about right there. 1/3 on the x-axis, down 1 is going to be about right there. 1, 0 is there. 3, 1 is right here, and 9, 2 is up there. Now I'm going to do a nice curve through this. Yeah, sorry about the noise effects. There we go. And I'm going to now graph the point or the line y equals x. And y equals x has a y-intercept of 0, so 0, 0, and it has a slope of 1. So the line y equals x is this line right here. I know there's a way of doing a fancy line on this, but another day, right? Okay, so y equals x is right there. And notice, if you were to fold this graph right on that line y equals x, the purple graph and the green graph would overlap, which is the definition, of course, of an inverse. So it is reflecting or mirror image over the line y equals x. Now, we could even do one better. If you look down here, the domain, I'm going to switch it back to green so we have everything. Actually, let me just do this first. Green. The domain is not anymore all real numbers. It's making sense from 0 and greater. So really, the domain is x is greater than 0. Notice this right here. The domain is the range, and the range is the domain for the inverse functions, which is really, really nice to know, so that if you can't figure it out, you could always graph the other function and look at the pattern. The range is where y makes sense. That's going to be all real numbers. The asymptote isn't y equals 0, it's x equals 0. Now it's the y-axis. And the x-intercept is at 1, 0, not 0, 1 like over here, but 1, 0. But there's those patterns, right? And the y-intercept, where does it hit the y-axis? It doesn't. So notice everything is flip-floppy, if you want to think of it that way. You know, it's great that way. So with that said, what we just did in the green is graph the logarithmic function y equals log base 3 of x. So you did just graph the inverse of y equals 3 dx, which is a logarithmic function. So I'm going to keep mentioning that a logarithmic function is the inverse of an exponential. That's what you really need to kind of get out of this. Coming down here, it says a logarithmic function log base b a equals c. And notice I wrote it right here. The expression log base b y is read as log base, this is the base right here, base b of y is equal to c in this top one. And notice that this switches to this or vice versa. So I do want you to really note something though, and this is really the trick to logarithms, is that if you note, I just went into a weird color. If you note that in an exponential function, the exponent is c right here, right? Let me just, I can't make it bigger. I don't know how to make it bigger. But the exponent over here is c. There's your exponent. Notice that a logarithm, when it's in logarithm form, the exponent is actually what it's equal to. So there is the exponent. So if you can see that, then you can kind of see how they're related. So you can switch them from back and forth with that idea. Now, when I remember looking at this for the first time and thinking, oh my gosh, what just happened? We're going to be doing these a lot, switching it back and forth. So in a very short amount of time, you're going to be like, oh, okay. So if you're just trying to see this pattern, that's great. But just know that we're going to have lots of examples down below. So just kind of bear with me here. So let's kind of go back to graphing, and then we'll get into actually evaluating logarithms. So let me just kind of make sure that you're seeing it all. It says graph f of x equals log base 5 of x. So I want to graph this. And then I want to graph the inverse of that. label the important characteristics of each graph. So I do want to say, if you've never seen this notation, that does mean inverse. So we're just talking about the inverse of x, which is this log base 5 of x. So let me first do this. I'm going to, because we've not seen logarithms for very long, I'm going to take this and actually switch it over into exponential form, because for me it sometimes helps a little bit. So I'm going to first write this as y equals log base 5x, and I'm going to say, okay, the base is 5 raised to the exponent, which we know as y, equals x. And if you're like going, ooh, how did you get that? Well, it's kind of what we were talking about right up here, switching from this form to this form and back and forth. So I'm doing it in that form just because it's a little bit easier at the beginning to graph functions, logarithmic functions, when they're in exponential form versus the logarithmic form. Now the inverse, of course, we know is just swapping the x and y. So I'm going to say 5 instead of y, I'm going to say is to the x power equals, instead of x, it's y. So this is the f of x function. I'm just going to write it down here. And this is the inverse of that original, of that original function. That's a -1 right there. Okay, so now I'm going to just tell you this. What I find, just like what we did earlier, find is using -2 to 2 tends to work the best. Of course, you can change it. It's not set in stone. But I'm going to actually do the exponential first, because we're a little bit more used to doing inputs for x. So I'm going to say -2, -1, 0, 1, 2. Now, if you're doing a logarithmic function, what you're doing is putting values in for y. So instead of putting the values for x, I'm putting them in for y. -2, -1, 0, 1, 2. So that kind of just starts you off here. So I just want to let you know that that's really the beginning here. Then from here, you're putting -2 in. That's going to give you 1 over 25. That's going to be a tough one to graph, obviously. You put -1, you get 1/5. 0, of course, is 1. And then we have 5. And then we have 25. And you know what? We don't even need to think about this. We can just put the values that we found over there for x in for y over here, because they are inverses. And inverse is really just switching the x and y's around. Okay, so again, I should have color-coded. This one will be the green one. So I'm going to graph that one first. So -2 on the y, 1/25 was about right there. 1/5, -1. And you know, the graphs all kind of look similar, just like the exponentials that we did last section. So notice we've got a nice logarithmic function, although I probably can do better. Sorry, you guys. I just what I don't want it to look like is that it's, these styluses are, I want it to look like it's going closer and closer to the asymptote. And then the inverse, let's graph that. Actually, you know what I'm going to do? I'm going to do that line y equals x first, because you know what? Sometimes that just helps get my head in the right place with these graphs. Okay, I don't know. Let's go blue. So this one's going to be in blue. And as you can probably imagine, you can do this pretty quickly. And then what do we have there? 5, 1, oops. Or 1, 5, I mean. I was looking at the wrong one, so all of a sudden I was hesitating. And I'm going to graph it in really nicely. Oh, crap. Oh, sorry. There we go. Top-notch videos, right? Okay, so this here is my inverse. So I'm going to label it. I don't have to write the whole thing. I can just write f to the -1x. And then I'm going to switch this back over to green and label this one as f of x. If you want to write the whole thing, that's fine. But you need to label them, obviously. It does say label the important characteristics. So let's do that. We know that, since I'm in green, let's do the green. We know that the asymptote down here is x equals 0. That's important. We know this point right there is important. I'm going to label it as 1, 0. And we have the reflection line. And then I'm going to switch it over to blue and do the characteristics of my inverse, which we know the asymptote y equals 0 is important. And we know that this point right here, 0, 1 is important. So when I say label them, that's what I'm referring to. So nothing too fancy, but just kind of making sure you know the expectations. Okay, so graphing a function and its inverse when they're exponentials and logs. This is the steps. So the first example and this one should do the job for that. Now I'm going to stop actually, and I'm going to do, just because I don't want to feel rushed, I'm going to do the second part as part A. So I wanted just to part A was just, I wanted to explain what the inverse component with the exponentials and logs are and how to do that. But now we're going to get into evaluating, and that'll be my part B video. So tune into that to finish this note guide. Thanks.